Hi everyone, this is Mr. Sikandar from Varsity. In this video lecture, we'll be learning about a Python data structure called a set. You may know about lists and tuples, but sets have unique features that make them very useful in specific situations. Let's explore what they are, how they work, and why you want to use them. In this session, we'll be learning about the basics of set, like how do we create a set. We'll be learning about how do we access the elements of set, how to add and remove element from a set, and set specific methods like union, intersection, difference between two sets, and symmetric difference. We'll also be understanding about given two sets, what is the relationship between them? Are they like one is superset of the other one, or is one is subset of the other one, or they are completely disjoint sets? So let's start with the definition of a set. A set is a collection, meaning a group of elements of unique elements. So basically, a set is a collection, meaning, it's a data structure which can hold a group of elements, but unique point is it's a collection of unique elements. Duplicates are not allowed. The next point is it's unordered data structure. Okay. Whereas when you study about the list and tuple, we basically say that it's ordered data structure, meaning the elements will be stored in the same order in which you have inserted. Whereas in a set, okay, it is unordered. It does not maintain any specific order. The next point is there is some restriction on the kind of elements what we can add into a set. Okay. So the elements of the set must be immutable. Immutable meaning non-modifiable elements. We'll try to look at it in more detail later. What kind of elements can we add into a set and what kind of elements we cannot add into a set. But yes, set data structure is mutable. Okay. Now here, in these 2 points, you might see this term immutable and mutable. See, here it says elements of a set must be immutable, whereas it says that set is mutable, meaning we can add elements to a set. We can even remove elements from a set, but the elements, whatever you add in that, those elements should be a non-modifiable elements. Okay, let's see how do we create a set. There are 2 ways of creating a set. One way is you use a flap braces and inside that you put in the group of elements. So I can just say a set of numbers. So I'd like to print set of numbers. Add inside the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. In this particular case, you might think that it is maintaining the insertion order. It's not guaranteed in every cases. Okay. Next, these were a collection of unique elements already. Now, we have seen that so we know that a set does not support duplicates, right? So let us try to verify what happens in case if you have duplicates. I have some elements and now you can just observe I do have duplicate elements. This is okay, a duplicate elements, and I'll try to write set of numbers again. I'd like to print set of numbers. When I try to run this, so please do observe how many elements we had inserted. 1, 2, 3, 4, 5, 6, 7 elements. But how many elements do we have? 5. What's the reason? We had 12 2 times, but you can see 12 is present only once in the final list. Whereas same case, 23 was present only once, so it is also present in the final list. 34 was present twice. Okay, so you can just see. So any duplicates will be removed. Okay, only it's a collection of unique elements. And we can also observe it has not maintained any specific order. Fine. Now, let us see how do I basically create a set of one element, and also we'll try to learn how do we create a set of zero elements. So set with one element equal to, I can just pass on any value here. I'd like to print what is the set of one element. Okay, we can see that. Yes, if you want, you can also try to see the type of this particular one, set of one element. Fine. Okay. Next, we'll see how do we create an empty set. Empty set. So will this statement create an empty set or not? First, let us see the output. Then we'll try to look at the type. So we could see the empty flower braces, but we'd like to understand, is this a set? On observation, what we learned is this is not a set, it is basically a dictionary. This statement does not create an empty set. Okay, this statement does not create empty set. Okay, then how do I basically create an empty set? If you want to create an empty set, then we have to take the help of a function called as set. This one will create an empty set. Okay, right. Next, we've seen the one way of creating a set of elements by putting all the elements in the flower braces separated with a comma. Now, there is another way by using a set function. We already used it to create an empty set. We can also use this to create a set with an already existing collection of elements. Let us say we do have some numbers, and here these are initially stored using a list. Okay, where I also have some duplicates. 23 is duplicated and 45 is also duplicated. Now after that, I'd like to create a set by passing these numbers. So here you can just observe that duplicates are removed and it has also created a set here. Fine. So if you just want to have a look at the nums, that will be the list of original numbers. The insertion order is retained. Whereas in a set, first thing is duplicates are removed, and the next thing is we cannot guarantee about the order in which the elements will be present. Fine. Now, let us take another example. Let us say we'll try to write World Cup winners. Okay, and let's consider the World Cup winners in different years. I'm considering the 50 over or 60 over ODI cricket, wherein first, okay, World Cup basically happened in 1975, where West Indies had won that. And then second World Cup, which happened in 79, again West Indies had won that. Then 83, we had India, which had won the World Cup. Then same way, 87, Australia had won that. And then 1992, Pak had won that. Then 96, okay, SL Sri Lanka had won that. And then 99, okay, we know that Australia had won that. Then, okay, 2003, again, Australia had won that. And then, okay, more details like 2007, then 11, 7, again, it was Australia which had won that. Then India had won that. Okay. Then we basically had England winning that in 2019. Fine. And then again, Australians, which basically won it in 2023. Okay. Now, here, I just wanted to know the countries which has won World Cup. I'm not interested in which country has won how many times, right? So in that case, since you're only interested with respect to which countries have won, which countries have won the World Cup at least once, not bothered about how many times they won, then we can just use a set of World Cup winners. Okay, this is set of World Cup winners. I'm just trying to print both. Okay, so if you look at the list, yes, you get everything. But if you look at the countries which has won at least once, right? We can see West Indies, India, England, Sri Lanka, Australia, and Pakistan are the countries which are basically won at least once. So in case if you just wanted to know the number of unique elements into a particular collection, we can always convert that into a set, right? So another example is, assume that you have a string and I'd like to find out how many unique characters are present in the string. So the string could be, I'll try to write S equal to, or I can say, I'll try to take up this name of a city, which is basically Bengaluru. How many unique characters does it have? I'll try to write set of city and I'd like to print that directly. So you can just see they're basically 8 characters. Fine. How many characters it had originally? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many we got it in the final one? It is 8. Okay. So if you want, you can also try to print length of city. It basically give me 9. And I can also try to print city name. And then here, I just want to write unique characters. Right. So I can try to print the length of unique characters as well as the unique characters. Clear? Yes, if you want to combine a collection of strings into a single string, we can basically use the join method. Okay, but I'm not using that in this particular case. Right. So we learned how do I basically create a set using 2 different methods. And next we'll try to learn about this point. Elements of a set must be immutable, right? So what data structures are mutable and what data structures are immutable? So till now, with respect to data structures, we have already studied about list and tuple. List is mutable, whereas tuple is immutable. And then string is again immutable. Okay, set, as I said here, that set is basically a mutable data structure, right? Set is basically a mutable data structure. Similarly, we also have a dictionary. Okay, we call it as dic or dictionary. It is again a mutable data structure. Now, we have added primitive types like integers and characters or strings already. So let us try to write adding up this list as an element to a set. So I'm trying to create a set where, yes, one numerical value, we already seen this works, float value, we'll try to see it. Then I can print in string here. So as of now, I have inserted integer, float, and string. There's no problem. I'd like to add a tuple here. A tuple is again a group of elements enclosed in parentheses. So I'll try to add up those elements and you can just see this is valid. Okay, till here it is valid. If you want, you can capture this. And if you want, you can also try to print yes and type of yes. Okay, it's basically said everything is valid till here. Okay, till here it's valid. Now, what is not valid is if you have added a list, one element of, okay, any more than one element, but if it is a list, then it is invalid. If it is a list, it is invalid. Okay, can you see? List is invalid. Similarly, if you have another set as an element, if you basically try to have a set as another element here. Okay, even this is not valid because this basically creates a set and we cannot have set as an element of a set. Okay, on same lines, a dictionary cannot be an element of a set. Okay, we are yet to study about dictionary, but yes, we accidentally saw that how we ended up creating an empty dictionary. On the same lines, I'd like to create an empty dictionary out here, and you can just observe that it says that unhashable type dictionary. Okay, the reasons why they were not allowed is because it has a list, it has a set, it has a dictionary. Fine. So we learned that we cannot place mutable elements as an element of a set. Okay. We'll learn about how do we add elements into a set and remove elements from a set very soon. Now the next question is, how do I access the elements of a set? We have been printing the elements of a set, right? If I have a set of elements, we have been printing all the elements. Okay. So this is something which we have been doing it. So we know how do we print all the elements. But let us say I would like to access one by one. So if you want to access the elements one by one, I can write for loop and I can specify the set out there and we can try to print the elements one by one. This is valid. Now the question is, can I access an individual element using an indexing? Question is, can I access individual element of set using indexing? Okay, like can I basically write, I have a set, I'd like to write s of 0. And please do observe this statement is throwing an error because set object is not subscriptable. So you cannot use indexing to access the elements. Okay. So since you cannot access any specific element of a set, you cannot even modify any element of a set. Remember, you cannot access individual elements of set, okay, using indexing. Okay, yeah, for loop we can always use it. So since we cannot access any specific element like first element, second element that particular way, we cannot modify elements of set. We can remove elements, but we can add elements, but we cannot modify elements of a set. Fine. Okay. Next. Okay. So now let us try to learn how do we add elements to a set and how do we remove elements from a set. In order to add elements to a set, it provides me two methods. Like it provides me a method called as add and also provides me a method called as update. The add method is similar to the append method of a list, but append will always assure that that new element gets added at the end of the list, but add method will add an element, but after that, if you observe it, it might not be at the end. Okay, so it does not specify any order. Fine. And the same way, update is similar to extend. Okay, so we'll try to look into that. First, we'll try to have some set of numbers. You can also have an empty set. Perfect. Then after this, I'd like to add this element. So you can just observe. I'd like to first print that and add the elements. We added the element here. We can just observe the element got added, but yes, it's not necessarily at the end. Okay, right. Same way, if you have a group of elements into some collection, and if you want to add all those elements into a set one by one, then you can basically take the help of update. Fine. Now let me just try to have some numbers here. I do have some numbers. After that, I'm trying to use an update. But please do observe, I already had these 4 elements into a set. I already had these 4 elements, okay, in the set. If you want, you can again print set of numbers, what we already had it. Okay, and we also know that set does not support duplicates. Here, originally we had these elements. After that, you try to add 12. 12 was already existing, so new 12 was not added. 23 was already existing. 45 was already existing. 56, 67, and 78 were added. So you can just observe 3 new elements were added. Earlier, the size of the set was 4. Now 3 new elements were added. Fine. Okay. Now remember, for update, what we need to pass is again a collection. That collection can be a list or a tuple or another set. Okay, fine. That's perfectly okay. Clear? Right. Now, how do I remove elements from a set? Okay, deleting elements from set. Okay. For deleting elements from a set, it provides me 3 different methods. It provides me the remove method. It provides me the discard method, and it also provides me the pop. We'll try to understand each of this, what exactly this remove method does, what exactly this pop method does, and okay, discard method does. Okay, so I have these elements and I'd like to remove. So we use the set object dot remove. You pass on the element, and remember the element is existing as of now. I'm just using a remove, okay, to remove the elements. So you can just observe it removes perfect. Okay, right. Now, if the element is present, we know that it removes the element. Let us try to also see what happens if I try to remove an element which is not present. I'm trying to remove 90. 90 is not present in the set. So in case if the element is not present, it throws an exception called as key error. Okay, remove if element found present, it deletes it. Whereas if the element is not present, it throws an exception. Element not present, it throws an exception. Throws or raises an exception. Fine. Okay. Next, let us try to look into discard method. Discard is very similar to using the remove method. Discard. Okay. We have the set of elements. After that, I'll write set of numbers dot discard. Okay. Now please observe 45 was already existing. If the element is existing, so you can just observe it deletes it. Okay, it just deletes it. Yeah, if you want, you can try to print before as well as after. If you want, you can also capture that. Okay, I'll say deleted element. And later on, if you want, you can say okay. So what we learned out here is discard does not return me the element which is deleted. It just deletes that. Fine, perfect. Now, what happens in case the element is not present? Okay. So now assume that we don't have this element 90. So what it does in this case? Does it throw an exception? The answer is no. The main difference between the discard method and the remove method is remove method throws an exception if the element is not present, whereas discard method does not throw an exception when the element is not present, right? Okay, so discard does not throw an exception when element is not present. Okay, when the element is present, both are exactly same. Then the next one is pop, pop method of set. Okay, so now we have already studied about the pop method in a list wherein the pop method was basically used to remove element at a given index, and by default it was removing the last element. If you want, we could even remove the element based on the index. But the pop method in a set does not take any argument, and it does not remove last element because there's okay, we cannot specify which one is the last element. It randomly deletes one element. It randomly deletes one element. Which element we cannot assure. Some element it deletes. So here we could see 34 was deleted. Okay, but yes, there's no assurance that it will delete 34 only. It can delete any random element. Okay, right. Now, yeah, we can also have a look at the help, and we can try to write set of numbers dot pop. I'd like to demonstrate the documentation of the pop method. Remove and return an arbitrary set element. Here, a random element will be selected, and it will return that, and it will also remove that. But yes, if the set is empty, it throws an exception. Okay, so I hope the concept is clear. How do we basically remove elements from a set with the help of remove method, the discard method, and even the pop method? Okay, now let's move into the set operations of Python's data structure, which we'll try to now let's move into studying about the various set specific operations provided by the Python set class. Okay, now given two sets, you can basically perform union of two sets or intersection of two sets. We can also find out the difference of two sets, and we can also find out symmetric difference. Okay, we can find out the symmetric difference. Right. We'll try to understand each of this. What exactly do you mean by a union, and how do I basically perform a union, and what exactly is an intersection, right? Okay. So we'll try to consider two set S1. We have a set of elements S2. Let us say we do have this elements 34, 45, which is present in first one as well as second one. Okay. So the union of these two sets is basically one set which consists of elements of this as well as this, but the common elements should be present only once. The common element should be present only once. So the result should be like, okay, or if you have to pictorially demonstrate that, we can demonstrate in this way, where you have one set and you have another set. So the first set basically had this 12, 23. It also had 34 and 45. The second set had 34 and 45. Then it also had 56 and 78. Okay. So we can observe that 34 and 45 are common for both the sets. So union of these two sets is like the entire thing, which consists of first set elements, second set elements, as well as the common elements. But the common element should be present only once. Now, how do I basically perform a union of two sets? Again, there are two ways to perform all these operations. One is using the operators. The other one is using the function names. So let us try to use the operators. The operator, what we use it is S1. We use the same symbol as bitwise or pipeline character. We try to specify the second set object, and here we can try to print this. So you can just observe we had 6 elements, 34 and 45 is present only once. Okay, so the other way of doing the same operation is I can try to write S1 dot union and I can pass on S2. Okay, so you can just observe this is a union of two sets. Fine. Now, I'd like to look into the intersection, meaning the common elements of these two sets, the common elements of these two sets. So if you want to find out the common elements of these two sets, again, it provides you an operator as well as it also provides you a function. We use the ampersand. This basically gives me the common elements which are present in S1 as well as S2. The same thing if I basically wanted to do with the help of method, I can just use intersection. I can pass on this. This also provides. Okay, right. Now, given two sets, I'd like to perform this difference. Like for example, if I have this S1 and S2, I would like to remove those elements that are present in S2 from S1. So what we can actually do it is, I can write S1 minus S2. Get me all the elements of S1, but don't consider those elements which are present in S2. So the elements which are present in S2 should not be considered. Other than that, the elements which are only present in S1, discard those elements which are also present in S2. But remember, S1 minus S2 is different when compared to S2 minus S1. Because S1 minus S2 is this portion, whereas S2 minus, okay, S1 is, this is overall S2 minus this portion, we get 56 and 78. We can also try to verify this. Right? Okay. Now, there's one more thing called as symmetric difference. Symmetric. Yeah, this also you can also do it with the help of like S1 dot difference of S2. Same thing. Okay. Now, symmetric difference is basically, I would like to find out all the elements excluding the common element. Excluding the common element. Common elements are 34 and 45. Excluding that, I would like to get every element of S1 and S2. So how do I basically do that? S1. This is the symbol for symmetric difference. S2. Same thing with the help of a method called as symmetric difference. So excluding the common elements, I'd like to get every other element of it. Given two sets, we can find out if one is a complete superset of the other one, or if one is a subset of the other one, or they are completely disjoint sets. Okay, let's consider two sets. Let us consider this set and this set. Okay, so let us consider the elements. Let's say we have some 12 or single digit number. Let us say these are single digit numbers 1, 8, 10. Okay, and then let us also consider some of the two digit numbers 12, 45, 89. Okay, right. Now, I'd like to create two sets. Represent that. One is single digit number, single digit numbers. Given two sets, I'd like to find out what is the relationship between them. Like, is one a completely a subset of the other one, or one of them is a superset of the other one, or they're completely two unrelated. Let us consider an example like this, where The inner circle, I'll say it's a set of single digit numbers. Like I can say 1, 5, 8. Okay, all these are basically single digit numbers. And the outer circle is basically representing all the numbers up to 100, which includes the single digit numbers and might be some 2-digit numbers also. Okay, right. So let us try to represent that. Now, what are the elements of S1? The S1's elements are 1, 5, and 8, or I can say single digit numbers. Okay. Then S2 is basically 1, 5, 8. Okay, because it's also 1, 5, 8 is also part of the larger circle. Then 12, 34, and 67. Right? I'd like to find out, is S1 a subset of S2? Yes. Okay. Then the same way, if I would like to write down if S2 is a superset of S1, S2 is a superset of S1, S1 is a subset of S2, right? But doing the reverse, okay, doing the reverse of this is not possible. When I say reverse of this, is S2 a subset of S1? The answer is no. Is S1 a superset of S2? The answer is no, right? S2 is a larger set and S1 is subset. Remember, all the elements which are present in S1 should also be a part of S2. Only then it will be considered as a subset. Okay, otherwise it will not be considered as a subset. So we just saw how do we verify if one is a subset of the other one and if one is not a subset of the other one, right? Now, there's also a method like, are they disjoint sets or not? In this particular case, they are not disjoint. Okay. So here it returns me false. And assume that we had two sets. There's no connection between this. There's not even a single element which is common, right? So in this particular case, are they disjoint? It says yes. Okay. So we basically learned the things like what exactly is a set. Then we learned how do we create a set, how do we add elements to a set, how do we remove element from a set, and various set operations. I hope all the concepts what we studied is clear. Thank you.